You step onto a massive cargo ship carrying thousands of containers across black water. And despite weighing hundreds of thousands of tons, it moves through the ocean with an almost unnatural smoothness. But hidden beneath the waterline is something strange. A giant underwater nose sticking out from the front of the ship. It looks ugly, oversized, and completely unnecessary. Yet that strange metal bulge quietly saves the global economy billions of dollars every year because the ocean is constantly fighting against movement. Every ship pushing through water creates resistance, and water punishes inefficiency harder than almost anything on Earth. Humans discovered this problem thousands of years ago, when early boats made from logs and animal skins struggled against rivers and currents. The harder people paddled, the harder the water pushed back, which meant more energy burned and less chance of survival. Then trade empires arrived, and suddenly speed became wealth. Faster ships delivered spices, gold, and weapons sooner, while slower ships lost money, lost trade routes, and sometimes lost wars. But sailors eventually realized something important. Ships were not only fighting waves, they were creating them. As a ship moves forward, water piles up at the front of the hull like snow building in front of a plow, and that pressure wave creates enormous drag. The faster the ship moves, the worse that resistance becomes. Bigger engines helped, but they also burned enormous amounts of fuel, and the ocean always demanded more. That is where the hidden mechanism appears. The underwater nose is called a bulbous bow, and it works using wave cancellation. As the ship moves, the bulb creates its own pressure wave underwater, and that wave collides with the natural wave, created by the ship itself. The two waves partially cancel each other out, which reduces resistance and allows the ship to move more efficiently through the water. Less resistance means less fuel burned, and that changes everything because modern cargo ships transport nearly 90% of world trade. Food, oil, medicine, electronics, cars, and countless other products spend part of their lives crossing oceans inside these giant steel machines. Even a small reduction in drag saves massive amounts of fuel over long distances, and some bulbous bows can reduce resistance by around 15%. That may sound small, but across thousands of ships traveling every day, it becomes billions of dollars saved globally. But the design only works under specific conditions. The bulb must match the ship's size, speed, and operating depth almost perfectly. If the shape is wrong, or the ship travels too slowly, the effect disappears completely, and can even create more drag instead. That is why giant container ships use bulbous bows constantly, while smaller tugboats often do not. Modern naval engineers spend years designing these shapes because tiny adjustments can produce enormous efficiency gains at sea. The bulbous bow also improves stability by changing how water flows around the hull during rough weather. Without that control, ships slam violently into waves, cargo shifts dangerously, and metal structures slowly weaken under repeated stress. In many ways, this strange underwater nose quietly protects global supply chains from collapsing under the pressure of distance, weather, and fuel costs. Most people never think about hydrodynamics or pressure waves while shopping for groceries or ordering products online, yet hidden systems like this keep modern civilization functioning every single day. And the strangest part is that the design looks completely wrong to human instincts because we naturally assume sharp shapes move faster through water. But at the scale of giant ships, controlling pressure matters more than slicing cleanly through the ocean. The bulbous bow does not overpower the sea. It negotiates with it. That is why it works, and that is why one strange underwater shape quietly helps keep the modern world alive. Subscribe for more hidden systems shaping your world.